All right, today we are talking about 614 flowcharts for congruence. And if we remember this first question, 629 is talking about taking us back to this question from the first section of chapter 6, which is 6-2. And we made a flowchart to prove that these two triangles were similar. We used rocks to show that by SSS similarity, these two triangles were similar, okay? What I want to do today is I want to show you how to make a flowchart to prove that these two are congruent. And it's going to be similar to what we have here, but there's enough differences that I want to make sure that you understand the difference, okay? When we're showing that things are congruent, instead of putting rocks, what I'm going to do is, let's see, there we go. It's a little better. So when I'm looking at this same picture, what I'm going to do instead of saying the ratios, looking at ratios, I'm going to actually list the side lengths. So I'm going to say side length AB is congruent, AB is 6, to side length FD. Okay? And that reason can be given. I don't have to do any work. I can simply look and say 6 and 6 are the same. Okay? Then in my next bubble, BC is congruent to ED. Okay? Why? Well, that's also given. I don't have to do any extra work. I can just look and see that both segments are 4.4. My third bubble is going to have AC, which is 7.5, congruent to EF. Okay? Also given. Those three things, it's three sides in each triangle are shown to be congruent to each other. Now I can say triangle ABC is congruent, and I can use the same one I used before, to triangle FDE. Okay? The letters don't go out of order. If I say A, B, C, 1 tick mark, 2 tick marks. 1, 2 is FDE. Okay? The reason here is side, side, side similarity. Okay, now the next thing I want to do is use that same idea of a flowchart, but with a different set of triangles. We haven't seen this one yet. This is 6-31. If I'm going to make a flowchart here, I better pay attention to what kind of information that I know. And I can see pretty clearly that angle P and angle T are equal. Angle P and angle T are equal, and that's given. Angle P, congruent, angle T. I didn't have to do any work, given. Then I know these two angles, and I'm going to have to be careful in naming those. PRQ, angle PRQ, is congruent to SRT, angle SRT. And I could call it TRS or SRT for an angle. It doesn't matter. It does not need to necessarily match up with the other one. I just need to make sure that R, which is the vertex of both, is in the middle. The reason I know that those two angles are congruent is not given. That is the fact that vertical angles are always congruent. Okay, vertical angles are congruent. Okay, so I have two angles, angle, angle. But that's not enough to prove congruence. What I do have is this additional side. Okay? So I can say PQ is congruent to ST. And again, I didn't have to do work. I didn't have to figure anything out. That is given. So I have two angles in one side. And I remember from yesterday, two angles in one side. Two angles in one side. There are two different ways. If I look at just one triangle, I see my two angles. This side is not in between, okay? It has to literally be in between in order to use ASA. It is not in between. It is just touching one of the angles. So that's how I know I'm going to use angle, angle, side. Okay? I'm going to be careful here and say triangle. Now remember, PQR, that order does not matter for the first triangle. PQR, yellow, blank, blue. So I just have to follow the same pattern, yellow, blank, blue, TSR. Now, those two triangles are congruent by angle, angle, side, congruence. Okay, so that's a flow chart. We've done lots of flow charts this year, and some of you may like this new way of doing a proof, some of you may not. And what this is called is a 2-column proof. So we're actually going to use this same, I can do this without totally messing up my video. We're going to do the same problem, so it's got the same pictures exactly. And what I'm going to do now is I'm going to do what's called a 2-column proof, okay? And all I'm going to do is take this information and rewrite it in a different format. The 2 columns are called statements and reasons, and really the statements come from inside the bubble, and the reasons come from under the bubble, okay? So I could just go through this proof. The first 3 bubbles, just like in a flow chart, it wouldn't matter what order I put those 3 bubbles. It doesn't matter for the first 3. Any 3 are fine. So inside the first bubble, angle P is congruent to angle T. Reason, well, that's given. Then I'm going to take the middle blue bubble. Angle PRQ is congruent to angle SRT. Why? Because vertical angles are congruent. Okay? Third bubble in purple. Segment PQ is congruent to segment ST. That's given because they were both equal to the number 6. And when I have these 3 things, what that tells me as my final statement is what I'm trying to prove. Triangle PQR is congruent to triangle TSR by angle, angle, similarity, congruence. Okay? So, when you're doing flow charts or 2-column proofs, it's not very often that we're going to ask you to do both for the same set of triangles. Usually it will say, I want you to do a flow chart, or I want you to do a 2-column proof. Or maybe we'll say, you choose, okay? But you don't typically do both, but just so you know how it looks when you set up a 2-column proof.